Okay, so 3.3, I'm going to go back over the long division problem we did together in class, and then we'll keep going, okay? So we did pencil problem number 1, and so I know you already have it filled out, but I'm going to go back over it. So remember that make sure both your polynomials when you're dividing are in standard form, so largest exponent first and then in descending order, and make sure all the exponents from the largest one down to the constant are accounted for. If something's missing, you need to put a 0, x, whatever in its place. So we're dividing by the x minus 4, so I'm going to put x minus 4 on the outside. And we're dividing that into this here. Well, it is in descending order, but I see it's missing x cubed and it's missing the constant. So I'm going to put a 0 in both places. So we have 4x to the 4th plus 0x cubed minus 4x squared plus 6x plus 0. And it doesn't really matter if you put a plus 0 or a minus 0, they're the same thing. I just like plus. Alright, so remember we said that when we're dividing, we divide our first term. So 4x to the 4th divided by x is 4x cubed. And then when we multiply, though, we multiply to everything outside here. So this 4x cubed is going to go to both of these. So 4x cubed times x is 4x to the 4th. And 4x cubed times negative 4 is a negative 16x cubed. Then we're going to subtract, which means we're going to change the signs. Those should always cancel. So we have 16x cubed. And then remember you said we're going to bring down what's left. Bring down the rest. So minus 4x squared plus 6x plus 0. Then we just repeat ourselves. Divide your first term. So 16x cubed divided by x is 16x squared. It's positive, so put a plus there. Multiply that to everything on the outside there. So 16x squared times x is 16x cubed. 16x squared times negative 4 is negative 64x squared. We're going to subtract, so that means to change the signs. 16x cubed minus 16x cubed cancels. Negative 4x squared plus 64x squared is 60x squared. And then bring down the rest. So plus 6x plus 0. Okay, we're going to do it again. So divide your first term. So 60x squared divided by x is 60x. Multiply to everything on the outside. So 60x times x is 60x squared. 60x times negative 4 is negative 240x. We're going to subtract, which means to change the signs. And that gives us 246x, and then bring down the rest. Keep going. One more time. So we're going to take 246 and divide it by the x, which is 246. We're going to take 246 times the x minus 4. So 246 times x is 246. 246 times negative 4 is a negative 984. Oops, I forgot my x there. All right, we're going to subtract, so change the signs. And we end up with 984. Now this is our remainder, so we're going to come back up to the answer. We're going to put a plus sign, and you're going to put your remainder over what you divided by, which was the x minus 4. And so this here is our answer. So let's try looking at number 1 now. All right, so I'm going to clear that side so it doesn't look so messy. And I might, with me writing big, I might go over a little bit. Okay, I can see that we're dividing by x squared minus 2x. It is in descending order of the exponents. I notice there's no constant, so I'm going to put a 0 there. So I'm going to have x squared minus 2x plus 0 on the outside. All right, divides into 2x to the 4th plus 3x cubed minus 7x minus 10. It's in descending order. The x squared is missing, so I'm going to put a 0x squared for that. So we have our 2x to the 4th plus our 3x cubed plus 0x squared minus 7x minus 10. And now we're just going to divide. So divide your first terms, 2x to the 4th divided by x squared. If you have to, guys, write it out, okay? There's nothing wrong with that. So that gives me 2x squared. Remember, you're going to take this and you're going to multiply it times all three of those terms. So 2x squared times x squared is 2x to the fourth. 2x squared times negative 2x is negative 4x cubed. And then 2x squared times 0 is 0x squared. You're going to subtract, so change all the signs. Those cancel. 3x cubed plus 4x cubed is 7x cubed. And 0x minus 0, or 0x squared minus 0x squared is still 0x squared. Still going to keep it in case I need it for a placeholder, okay? And then bring down the rest. So minus 7x minus 10. Then we're just going to keep repeating. So we got 7x cubed divided by x squared. That's going to be 7x. Multiply everything on the outside by the 7x. So 7x times x squared is 7x cubed. 7x times negative 2x is negative 14x squared. And 7x times 0 is 0x. Subtract them, which remember means change the signs. So we got 0x squared plus 14x squared. Negative 7x minus 0x. And then we have our bring down the rest, so bring down your minus 10. Now notice your x squared on the bottom is the same as x squared on the outside, so this is our last time. So 14x squared divided by x squared is 14. Multiply that 14 times everything on the outside. So 14 times x squared is 14x squared. 14 times negative 2x is negative 28x. And 14 times 0 is 0. We're going to subtract, so change all the signs. So negative 7x plus 28x is 21x. And negative 10 minus 0 is still negative 10. Because this x right here has a smaller exponent than the x right there, that means we're done. This is our remainder. So we're going to put plus our remainder, which is the 21x minus 10, over what we divided by. Now, because we did add a 0 in what we divided by, we don't have to put the 0 in it. We were dividing by x squared minus 2x. And so you can just put it like that. And so there is our solution. All right. So then synthetic division. I started trying to show you this a little bit when when class was ending. So I'm going to look back at the pencil problem number 1, because that's the one I kind of started in class and some of y'all were paying attention to. This one I can use synthetic division for because it has an x plus or minus and a whole number there, okay, an integer. I can't do it on like the solved problem number 1 because it's got an x squared. You can't use synthetic division unless it's being divided by x and then plus or minus, and it has to be an integer there, okay? So what we think of as a whole number. So if we're going to do this, what we do is whatever this number is, we're going to change its sign and put it in this little box here, okay? And then we're going to write out the coefficients to everything that we're dividing into. And remember, same thing, they have to be in descending order of the exponent, so it has to be standard form, and anything that's missing we put a 0 for. So we're only going to use the coefficients. So we're going to take the coefficients of the first term, which is 4, and then we don't have an x cubed, so we're going to put a 0. Then we have a negative 4x squared, so negative 4. We have a positive 6x, so 6, and then we don't have a constant, so we have to put a 0 there. I'm going to skip a little space here, draw a line, and put a little box there. That little box is my remainder box, okay? And I'm doing it on this one so that you can see we get the same answer that we did when we did it previously. So I know you probably don't have room to write this here. You can put it on a sheet of paper, or you can just watch this one if you want to. All right, so we're going to bring down that first term every time. Anything that goes on this bottom row right here is going to get multiplied by that number there. So 4 times 4 is 16. So we put that here, and we're going to combine them. It's a positive 16, so we're going to add. 0 plus 16 is 16. It's on that bottom row, so it's going to get multiplied by 4, which is 64, so we put it up here. It's a positive 64, so negative 4 plus 64 is 60. It's on the bottom row, so it's going to get multiplied by 4. Goes into that next column. 4 times 60 is 240. It's positive, so we're going to add. 6 plus 240 is 246. It's in that bottom row again, so it's going to get multiplied and put into the next column. So 4 times 246 was 984. It's positive, so we're going to add. 0 plus 984 is 984. Now, in the original problem, we were taking an x to the fourth and we're dividing it by an x. So every time, because it has to be an x and then plus or minus a number, your answer is going to start with the variable that is 1 less than the problem. So this one was x to the fourth, so it's going to be x to the third. And these here, these numbers down here in this bottom row, those are my coefficients. So I'm going to erase some of these lines that I drew. So these are my coefficients. So I'm going to start out with a 4, and we said it's going to be 1 less on our variable, so it's x cubed, and then a positive 16, so we're just going to go in descending order of our exponents for our variables, so x squared, positive 60, x, positive 246 with no x, and then what's in that box? That's my remainder box, so plus my remainder over what we divided by. We're not really dividing by 4, we're dividing by x minus 4, so that's where you put the x minus 4. And so if you look at this and you look back to the answer we got doing long division, they should be exactly the same. All right, so it'll work. Now let's do some that are a little simpler. So let's look at the solved problem number 2. All right, so first let's check. Can we do division? Yeah, synthetic division, yes, because it's x plus an integer, okay? So we're going to take this number and we're going to change the sign and put it in the little box out to the side. Then we're going to make sure this is in standard form, and we're going to write all the coefficients from 1x cubed down to the constant next to that negative 2. So we have a 1x cubed. We don't have an x squared, so we've got to put a 0 there. We have a negative 7x and a negative 6. Skip a little space and draw a line. Underneath the negative 6, draw your remainder box. So remember, bring the first number down. Multiply it times the negative 2 and put that in the next column. So negative 2 times 1 is negative 2. Combine them. 0 minus 2 is negative 2. Multiply that by the negative 2, put it in the next column. So it's a positive 4. So negative 7 plus 4 is negative 3. Multiply that by negative 2, put it in the next column. So positive 6. Negative 6 plus 6 is 0. So we have no remainder. All right, so for my answer then, our problem started with x cubed, so our answer is going to start with 1 less, so it's going to be x squared. So my first coefficient is 1, x squared, and then minus 2x minus 3 as my constant, no x, and I don't have a remainder. So we just have x squared minus 2x minus 3. All right, so if you want to pause this so you can try to work this one, do so, and I'm going to go ahead and go through it. All right, so we're dividing by x plus 5 because it's x plus or minus an integer. We can do that. So we're going to take that positive 5 and change its sign and put it out in a little side box. Next to it, we're going to put the coefficients of the polynomial here. Make sure they're in descending order of the exponents, and remember, make sure every exponent from the largest one down is accounted for. So we have a 3x squared. I have a 7x and a negative 20. So we didn't have anything missing this time. Underneath the constant is always our remainder box. So bring down the 3. Remember, anything on the bottom row is multiplied by what's in that box there, so the -5, and is put into the next column. Then combine those. It's on the bottom row, so multiply by the -5 and put it in the next column. So +40, combine those, and so we have a remainder of 20. So our problem started with x squared. Our answer starts with 1 less. So it's 3x minus 8, and then we're going to put plus our remainder over what we divided by, the whole thing there, so the x plus 5. All right, so moving on. All right, so the remainder theorem. The remainder theorem just says that if I want to know if I have a polynomial here, I'm just going to use this solved problem here to talk about it. Okay, if I plug in f of -4, if I solve for that, it's going to give me the exact same answer I would get as a remainder if I divided by x plus 4. Change the sign when it goes back to the x, okay? So it's the remainder theorem because all it's going to show us is the remainder, what we would get in that little box. All right, so just like on the previous problem, you can just watch this one. We divided by the x plus 5. So if I would have found f of -5, this would tell me what was in that box. So if I plug -5 in right here, and solve it, we just said a remainder in that box is a 20. I should get a 20 out of this. So let's check. So 3 times 25 minus 35 minus 20. So this is what, 75 minus, put those together, and that's 55, or -55. Subtract them, and we get 20. It's what the remainder is. This can be important when we're trying to find out, is this a 0? Is it a factor? Remember, factors divide into things evenly, so it has a remainder of 0. So it is useful sometimes. So let's try this. On number 3, the solved problem number 3, let's find what our remainder would be if we divided by the x plus 4. So we're going to find f of -4. All right, so I'm going to plug all that in, and guys, I'm going to be lazy. I'm just going to put it in my calculator. And if I put it in right, I got -105. All right, so it tells me my remainder would have been -105. It also tells me that the point -4, -105 is on this graph. Okay, they just kind of pointed that out in my teacher notes, so I want to make sure that y'all realize that. All right, so now the difference between earlier, now remember earlier it was like x, I don't remember what the problem was. Well, this one would have been like x plus 4. It's with the x. We had to change the sign. This is not with the x, so you just plug it in. You do what it says, just like we've done in the past, okay? When we had like f of x equals x plus 2, and I told you find f of 2, and you just plugged in 2, that you're doing the same exact thing there. All right, so look at pencil problem number 3. If you want to pause this, do so and work it out, and then I'm going to go ahead and work it here so you can check your answer. So I am just plugging in f of 4. I'm going to plug all this into my calculator here. And if I did it right, I get -25, which tells me if I did my synthetic division right there in that remainder box, I would get a -25. And so let's check that. 2x cubed, -11x squared, 7x, and a -5. I'm trying to make them line up there. Bring down your first one, times the 4, combine them, times the 4, combine them, times the 4, and looky there, combine them, and we did get the negative 25. All right, and then to use the factor theorem to solve a polynomial equation. So solve the equation that 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that negative 1 is a 0 of that. If negative 1 is a 0, that means that x plus 1 is a factor. And if x plus 1 is a factor, that means it's evenly divisible by it. So I can divide by the x plus 1 and be able to bring this down to something smaller so that I might be able to factor it out or to finish solving it. All right, now be careful because when they retyped it, they changed that to a squared. I just happened to notice that. All right, so I'm going to use synthetic division. So because it's plus 1, or they just said negative 1 here, we're going to put negative 1. I know it's going to be 15x cubed, 14x squared, negative 3x, and then negative 2. Now remember, since it's a factor, your remainder box should get a 0 in it. If it doesn't, we've made a mistake. All right, bring down the first term, times a negative 1, combine, times a negative 1, combine, times a negative 1, and combine. So our problem started with 15x cubed, so our answer, remember, is 1 less. So 15x squared minus x minus 2. Well, this is still going to be equal to 0. And so we know that we can write this as the x plus 1 times that now, okay, because we divided by x plus 1. It's just like if I take 30 and I divide it by 2, we get 15, so we can say that 30 is now equal to 2 times 15, okay? It's the same thing I'm doing here. I'm taking this polynomial, I'm dividing it by the x plus 1, so it's equal to x plus 1 times whatever our answer is. Now, we can keep working on this quadratic because now we can factor that, or you can use your quadratic formula. I'm going to factor this using that first times the last. The first times the last. So we end up with x squared minus x. Remember to multiply them. So I'm looking for two numbers that are going to multiply to 30, that are going to subtract to give me the 1. So it's 6 and 5. It needs to be a minus 6 and a positive 5. Don't forget you multiplied by 15, so divide the 15 out. Reduce it if possible. So they both reduce by 3, so that's what, 2 over 5. Reduce it if possible. So they both reduce by 5, so it's 1 over 3. And then since we're factoring, I'm going to put the number on bottom back in front of the x. Now I know that y'all didn't do that last year, and you really don't have to on this part because we're solving, but it's definitely a good habit to have. Alright, so I factored that trinomial, and I still have this x plus 1 here. And the problem still set equal to 0. Now we can do like what we did on Wednesday when we set each of our factors equal to 0 and solve. So we have that x plus 1 equals 0. We have 5x minus 2 equals 0. And we have 3x plus 1 equals 0. So when I solve this one, I get negative 1. Here we got 5x equals 2, so our x equals positive 2/5. And here we get 3x equals negative 1, so x equals negative 1/3. So all three of these are our solutions. All right, so if you want to try the second problem here, pause the video. I'm going to go ahead and work it. So it says solve the equation given that 2 is a 0 of that polynomial. So we're going to take a 2 here, and my coefficients are 2x cubed, negative 5x squared, 1x, and the constant is 2. So we're going to bring down that, don't forget your remainder box. Remember, if 2 is a 0, if 2 is a factor, then that means that, or x-intercept solution, then that means that our remainder is going to be 0. So bring down the 2, multiply it times that other 2, combine it, multiply it times the 2 in the box, combine it, multiply it times the 2 in the box, combine it. So it is a factor. So we know that if 2 is a 0, then its factor was x minus 2 times 2x squared minus x minus 1. Gives us the original polynomial that they gave us, okay? So we're going to set that equal to 0. Now I need to keep factoring right here. So this is where we do the first times the last. So it gives us x squared minus x minus 2. Remember, multiply them. So it's going to be x and x. And I need two numbers that multiply to 2 that will subtract to be the 1. So 2 and 1. The 2 has to be negative and the 1 is positive. Don't forget, because you multiplied, you got to divide back out. So we get x minus 1 times, that doesn't reduce, so put the 2 in front of the x, so 2x plus 1. And don't forget to bring down your x minus 2. And it's all equal to 0. So then set them each equal to 0 and solve. So we get x equals 2, x equals 1. And so here we got 2x equals negative 1, which means x equals negative 1/2. And so there are our three solutions here. All right, guys, so that is the end of 3.3. And so when I get back on Tuesday, we will start, we'll go over this real quick, and then we'll move on into 3.4.